All right, welcome. Today, we are diving deep right under the hood of those AI coding assistants. We're going to peel back the curtain, go past the slick UI, and really look at the clever engineering that makes these tools feel, well, almost magical. We'll follow a single command from start to finish. Have you ever really stopped to think about it? You type in a request, something like, hey, fix this bug. You hit enter, and then code just starts happening. What is actually going on in those few seconds? It's a pretty wild journey from your keyboard into the mind of the AI, and that's what we're tracking today. And right off the bat, the first thing we got to get straight is that these assistants are so much more than just beefed up chatbots. We're talking about really complex, sophisticated systems. They're engineered from the ground up to interact with your code, your files, your entire development environment, and to do it safely and efficiently. So yeah, to really get what's going on, we have to move past that simple chatbot analogy. Let's start by defining what these things actually are. Okay, so to really understand them, we need to talk about a core concept, the agentic system. It's a bit of a fancy term, but the idea is simple. It's not just a language model sitting in a box. It's really a combination of three key things. You've got the interface you see, right? Then there's the large language model, the LLM, which is kind of like the brain. And then, and this is the important part, you have a whole system of tools. Think of these as the hands that can actually do stuff in the real world, like read your files or run commands. Now, the entire architecture of these systems is basically built to solve three huge challenges. First, how do you get that instant feedback? How do you stop the whole app from just freezing up while the AI is off thinking? Second, and this is maybe the most important one, how do you keep it safe? You absolutely do not want an AI accidentally deleting your entire project, right? And third, how do you build it so that it can grow? So you can keep adding new tools and new capabilities without having to rebuild the whole thing from scratch. Okay, so to see how they actually solve those challenges, we're going to do something cool. We're going to follow a single prompt on its entire journey through the system, from the exact moment you type it in to the moment the AI actually takes action. So this journey has four main stops. First up, it starts at the user-facing layer. That's your terminal, your IDE, wherever you're typing. From there, it moves into conversation management, which is basically the part that figures out what you actually want. Next, it gets sent over to the LLM, the AI's brain. And finally, and this is where the magic happens, it interacts with the external world using all those tools we talked about. And the crucial thing here is that this is a loop. The AI can use a tool, see what happened, and then decide to use another tool based on that new information. It's getting smarter with every single step. All right, now for the really clever part, let's dig into the smartest architectural tricks that make this whole process feel so fast, so safe, and so responsive. These are the brilliant solutions to those big challenges we just laid out. Okay, the first trick is something called async generators. Now, don't worry about the jargon for a second. Just think of it like a streaming service, like Netflix or YouTube. Instead of having to download an entire 2-hour movie before you can start watching, it just streams it to you, piece by piece. Well, that's exactly what async generators do for the AI's responses. And this whole streaming approach is what creates that totally seamless experience we've all gotten used to. You get instant feedback, right? You see the text appearing token by token, word by word. Your UI never freezes, so the application stays completely responsive. And maybe best of all, you can hit that cancel button at any time, and the whole long process just stops, gracefully. It's all about making it feel like a real-time conversation. The next big idea is all about speed. You see, this system has a choice. It can do things one at a time. That's sequential execution, which is kind of like having a single checkout lane at the grocery store. It's slow but simple. Or it can do multiple things all at once, in parallel. That's like opening up 10 checkout lanes. It's way faster, but way more complex to manage. And the real genius of the system is knowing when to use which approach. And the source material really boils this whole decision down to one golden rule. It's this. Operations that only read information, those can all run at the same time, in parallel. But operations that change or write information, whoa, those need to be handled very carefully, one at a time, to avoid complete chaos. So let's see how this works in practice. Think about all the tools that just gather information. Things like viewing files, searching for content with grep, listing directories with ls. These are all read-only. The system can run dozens of these in parallel, just sucking in huge amounts of context in a fraction of a second. But the very moment the AI needs to change something, like edit a file, write new code, or run a command in the terminal, bam, it switches into sequential mode. This is such a critical trade-off for both safety and performance. It stops the AI from, say, trying to edit the same file in two different ways at the exact same time. And that brings us perfectly to what might be the single most important topic, safety. How does this architecture make sure the AI doesn't, do something really destructive? Well, it all comes down to giving you, the user, the ultimate control. The system uses this simple but incredibly powerful three-step permission model. Here's how it works. First, the AI tool says, hey, I need permission to do this potentially risky thing, like edit a file. That's the request. Second, you get a really clear pop-up, a dialogue, asking for your approval. And third, you get to decide. You can let it happen, just this once, or you can say always, and trust it for that type of action in the future. The point is, you are always in the driver's seat. Okay, let's zoom out for a second. All these architectural patterns we've been talking about, they're fantastic for a single developer working on their own. But what happens when an entire team wants to use an AI assistant? Well, the architecture has to evolve. And this leads to a pretty fundamental shift in how these systems are built, moving from what's called local first, where everything lives on your machine, to a server first architecture. A server first model puts all the data in a centralized cloud. And the huge benefit there? It makes real-time collaboration possible. Teams can share context, they can review the AI's work, but of course, it comes with a different set of trade-offs around things like privacy and complexity. So after all that, what's the big takeaway here? It really, truly is all about the architecture. These incredibly smart systems are built on just a few core principles. You've got streaming, which gives you that instant responsive feel. You've got doing things in parallel wherever possible for pure speed. You have clear permission boundaries to keep you, the user, safe and in control. And then there's the last one, recursive intelligence. Honestly, this is the real game changer. It's the AI's ability to use a tool, look at the result, and then, based on that new information, decide on a new tool to use. It's this powerful loop of action and learning that makes the whole system so incredibly effective. And that leaves us with a really fascinating final thought. As these agentic systems get more and more capable, and as they get more integrated into how teams work, they start to act less like tools and a lot more like actual team members. Which, of course, begs the question, if an AI can be a team member, who's the manager? Something to chew on. Thanks for joining us.